This section is about dilations. Remember that a dilation actually changes the size of your figure. So a dilation is not an isometry. The figure's size will change. It will not be congruent to the original. When you do a dilation, the angles remain the same size, but the lengths of the sides will be proportional to the original figure. So this is a similarity transformation, not an isometry. So in these first pictures it says, find the scale factor and tell whether the dilation is a reduction or an enlargement. The thing is, you have to figure out which one's the new one. That's extremely important. The figure that's the new one has the primes on it. This is the new figure here in orange. The original figure is the one that doesn't have the primes on it, like that one there. The center of this dilation, in this picture, they've connected the center to P and to P prime. This center is what it's dilated about. If I'm trying to tell the scale factor here, I would need the original distance that the figure was away and the new distance. And when you're figuring out scale factor, you want the new over the old. That's the scale factor. Of course, you'll reduce it if possible. So there's two parts here. Is it a reduction or enlargement? And find the scale factor. So the new one is smaller. This is a reduction. To figure out the scale factor, you want the new distance from the center over the old distance from the center. If you didn't have this particular picture, what you would do is the new side length over the old side length. With this picture, we have the distance it is out. So the new one is 5 away. The old one was 10 away. So this is a reduction, and the scale factor is 1/2. And the scale factor, they generally use K for that. So this is a reduction, and K is 1/2. Over here on the right, the new one, look for the prime. There's the new one. The old one is here. The new one is larger. It is an enlargement. And to get the scale factor, the new distance is 15. The old distance is 7. We can leave it like that as K, or we could figure out what that is as a decimal value. So 15 divided by 7 is 2.14, or it's 2 1/7. 2.14 would be K. And I want you to notice that if the K value is between 0 and 1, it is a reduction, and if the K value is more than 1, it is an enlargement. On the right here, they're wanting us just to practice if we have a matrix and we're going to multiply it by a scalar. This is called scalar multiplication of a matrix. All you're doing is you're taking that matrix and you're multiplying every number by the scale factor out front. Now notice that there is one with a negative number. For a dilation, you could never have a negative number because that K value is telling you how much to multiply it by size-wise. Negative number is not going to make sense. So in the first one, we're doubling everything. So for the product, we want to double every number in that matrix. So it would be -8, 6, and -4, just doubling everything. Doubling everything in the bottom row is 2, 14, and 0. And so that would be the new matrix. On the second one there, it's 2/3. Messing with your head with these fractions. And there's a decimal in there. So if you're multiplying a fraction by a number, sometimes people freak out over that. All you would do is multiply the numerator by the number and then divide by the denominator. So really that first one, 2 times 6 divided by 3 is 4. So for that first number, 4. Then we have 2 times -9 divided by 3 is -6. Anything times 0 is 0. Then we have 12. 12 times 2 is 24, divided by 3 is 8. Okay, now for this 4.5. 4.5 times 2 is 9, divided by 3 is 3. So it looked like it was going to be crazy, but it worked out really well. Then we have -6 times 2 is -12, divided by 3 is -4. So there's the new matrix for that. And then the last one of these, before we move on to really doing a dilation, just distributing -3. Anything times 0 is 0. -11 times -3 is +33. -2 times -3 is +6. 1 times -3, -3. 8 times -3, -24. And 7 times 3, -21. So there's the answer to that one. Okay, and then now for actually doing some dilations. We've got one with a scale factor of 1/2, so it's going to be a reduction. We've got one with a scale factor of 2, and that will be an enlargement. The question says find the image matrix, so we're going to use our matrix multiplication with that scale factor. Then we will graph the original and the image. So there's 3 things that have to happen. We need the new matrix, we need to graph the polygon, and the image. So those are the 3 parts. So the first thing I'm going to do is find the new matrix, A prime, B prime, C prime. When we're doing a dilation, all we do is multiply the scale factor with the matrix, so half of everything, so divide everything by 2. -3, -2, -1. 2 divided by 2 is 1. 4 divided by 2 is 2. 2 divided by 2 is 1. There we go. There's our points. Graph the original. -6, 2. There's A. -4, 2, 3, 4, 1, 2, 3, 4. -4, 4 is B. Then -2, 2 is C. That's the original. No, that should be straight third line. There we go. And then the new one is at -3, 1 for A prime, -2, 2 for B prime, and -1, 1 for C prime. Go away. No, go away. I'm making a video. For C prime. Jamie, don't talk. I am making a video. Shut the door, please. Sorry. Anyways, there's the new one. It is half the size of the old one. Also notice, since it's centered at the origin for this dilation, it is also half the distance the originals were from that origin. So like if I were to connect A to the origin and A prime to the origin, that distance would be half as much. All right, and then the last one on here, and the last one of the iBook, and I'm so glad because my whole family just got back from the park and they're being very loud. A prime, B prime, C prime, D prime, with a scale factor of 2, so we're doubling everything. So just double everything. Double check that we doubled everything. Okay, everything's been doubled. And we need to graph the original and the new one. So -3, -2 is A, -2, 1 is B, 0, 3 is C, and then 3, 4 is D. Looks weird. Let's connect it and see. Looks like a very skinny trapezoid. And then the new one is -6, -4. For A prime, -2, 1. Sorry, that was the old one. -4, 2. For B prime, 0, 6. For C prime, and 6, 8. For D prime, so the new one is there, and it's double the size of the original, and each point is twice as far from the origin as it used to be. And that's how you do dilations.